So by looking at those formulas, we see that this is the same as cosine 2x. And this also, that's another form also of cosine 2x, the double angle formula. All right, so therefore, we see that 1 minus tan squared x times 1 minus sine squared x equals 2 cosine to the power of 4x minus cosine squared x all over 1 minus sine squared x. Okay, so let's go down to here. We want to give a counterexample now to show that sine of x plus y equals cosine x cosine y plus sine x sine y is not an identity. Okay, so now instead of taking the complicated side and simplifying it to show that it does equal, to use a counterexample, what we want to do is we just want to choose a value for x and y, substitute them in to show that the left side does not equal the right side. Now there are perhaps many possible angles that may work here. We may find that pi by 2 and pi by 3, if x is pi by 2 and y is pi by 3, that may work. I don't know. Maybe pi by 6 and pi by 4 might work. That might actually make them equal. But what we need to do is we actually need to find one example where the left side does not equal the right side, and then we have therefore shown or given the counterexample such that the left side does not equal the right side. Okay, so what I'm what I'm just going to do here is I'm going to let x be, I don't know, why don't you pause the video and give it a try yourself and just try some values that could work. I'm going to try one myself here, but why don't you just kind of give it a little bit of thought and substitute them in, find the left side, and then find the right side, and then see if they're equal or not. And then if they are equal, try another combination of values, and if they do not equal, then you're set. You've found the counterexample. Okay, so please pause the video and give it a little bit of thought yourself, please. Okay, so what I'm going to choose is I'm going to say, well, let's let x equal pi by 2, and let's let y equal pi. Okay, so if we substitute pi by 2 and pi in for x and y, we get sine of 3 pi by 2. And the sine of 3 pi by 2, well, there's a few ways we can look at it. We can either look at it as a unit circle. The rotation, 3 pi by 2, would go all the way around to here. And we know that sine is the same as y. So if we take this as a unit circle where the radius is 1, then that means that that point on the y-axis would be 0, because that's cosine 1, or negative 1, which is the sine. Or we could also look at it as a sine curve, and we could say, okay, well, it looks something like that. There's pi by 2, here's pi, here's 3 pi by 2. And that, again, equals negative 1. So, either way you look at it, here sine of 3 pi by 2 equals negative 1. Now let's go over here and substitute these same values for x and y into this formula here. So the cosine of pi by 2 multiplied by the cosine of pi plus the sine of pi by 2 multiplied by the sine of pi. And then, again, either looking at it on a unit circle or looking at the cosine curve or the sine curves. And I'll just draw the cosine curve here, at least a rough sketch of it. So cosine of pi by 2, which is right there, that equals 0. Cosine of pi, well, pi is where it equals -1. Plus the sine of pi by 2. The sine of pi by 2 is 1. And the sine of pi, which is right there, sine of pi is 0. So 0 times -1 plus 1 times 0, that equals 0. And therefore we see that the left side does not equal the right side. When x equals pi by 2 and y equals pi. Therefore, these are counterexamples to show that sine of x plus y equals a cosine of x cosine of y plus sine x sine y is not an identity. Alright, so here is the fun for today. From page 470 to 418, 3 and 4, don't worry about graphing, that's okay. And then 5, 9, 10, 11, do the left column. If you want some more practice, then you can do the right column. And then page 408 from section 7.3, number 18. So please go ahead and do a couple of these at home tonight after you finish watching the video, and then come into class tomorrow and finish off the rest. So thank you very much for watching, and we'll see you in class.